for the optimization part. And I think you can recognize that this one is a linear programming problem, and this one is a non-linear programming problem. This one can be solved easily. And the difficult one is this. There are few variables to be optimized. One is the Q vector, and the other one is K. It cannot be solved directly. So what we need to do is to assign new set of arguments, new set of vector X. For instance, X1 equals to Q1, X3 equals to Q3, and also we have to assign X4 equals to K. So we have optimized the vector axis. So we have to rewrite the original mathematical problem into the argument of X and X. So this is the difficult part for this one. And also for this one, 4, not very clear, 4 minus 2K smaller than Q2 smaller than something else. What we need to do is to rewrite this part and this part separately to break this inequality to 2. And for this one we should have 4 minus 2K minus Q2 smaller than 0. And the other one is we have to Q2 minus the rest of it smaller than 0. So we have to break this one into 2 inequalities. In this case we can solve it.
I have a question. Is that one B and B? You have to use B and B, don't you?
No, it is not. It is a standard FMI&CO problem. It is not required that the arguments are integers. It cannot be a problem. Let me check. I don't think yes, it is a standard nonlinear programming problem. It has nothing to do with integers. X can be anything, as long as they satisfy the constants. And for this one, we have to redefine it, rewrite it into a solvable form with vector X rather than Q and K. So now I've talked something about the mixed integer programming problems. Now what about binary programming problems? As I said, binary programming problems require that xi's can either 0 or 1, and it cannot select any other constant. So how can we solve this kind of problem? In Matlab, there is a function called BANT_proc, which can be used to solve only binary linear programming problems, which we have F, A, B, and AEQ and DEQ. So it is quite restricted. It cannot deal with nonlinear programming problems. How can we solve nonlinear programming problems? There isn't an existing one. So we can still use BND pattern. And remember that we have to define S small m and S capital M in BNB 20 program. And if we assign all the elements here are 0 and this one are 1, and then we take integer programming problems, then it is a binary programming problem solver. So we can use it to solve binary programming problems with this function. And there is a simple example. I think you can try it, you can read it yourself, or you can try it later. And another topic, linear matrix inequalities. I'm not quite sure whether you use it or not in research. It is quite related to control problems. If you do not use it a lot, I will omit this part. Just related with control problems. So we can omit this part there. It's quite mathematical. Quite mathematical, so I will omit this part. And so now let's talk about something about dynamic programming. It is also a kind of optimization problem. And with the application, I will give a presentation on shortest path problems. And this is one of the examples. This is the example I want to use. Suppose there is a map where there are several cities, and there are roads from one city to another, and this is the time consumed on the road. So from city 1 to city 9, which road we should take to ensure that the minimum time used is the smallest? So this is the standard problem, or call it shortest path problem. And in this problem, we have several concepts. We have to introduce several concepts. One concept are the nodes. We call it the nodes. And the other one is the age. The road, the path, we call it age. There are a few terms to note here. One is node, age, and also the weight on each age. Remember here are the weights. So how can they find the shortest path for this map? Before we do that, we must talk about how we can represent such a map in mathematical form or in Matlab. From node I to node J, there is a path. We call it Wij. So how can we represent this in mathematical form? We can create a matrix, which means the ith row, jth column equals to. So we can use this notation to describe the graph. So if we can, we can assign all the elements in the matrix R in this way. Is that okay? So in this way, we can describe the map itself. So now how can we solve this particular problem? To solve this particular problem, what we need to do is to draw a table first, which is easily done. For instance, from node 1 to node 2, we have a weight of 1. From node 1 to node 3, we have a weight of 2. Then from node 2 to 5, we have a weight of 12. We can write out a table like this. Manually, with hand, we have to, with pen, pencils, we have